Hello students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. So those who are watching this particular live, just mark your attendance here. Hi Arush, good evening. So in the last class we have discussed the practice session for different chapters. 3 chapters we have completed. So today I am going to discuss a new chapter, carbon and its compounds. We will be discussing the complete introduction part of the carbon and its compounds. Hi Durgesha, good evening. So this will be the new chapter. We are going to discuss more important terms here, which we are going to discuss more about the higher classes only. So this is our learning objective for this chapter. From the name itself, we can understand it's about the carbon, right? So understanding the position of carbon in the periodic table and its ability to form diverse compounds. That will be one of our objective here. Then explain the concept of hybridization. I hope you must have studying about the hybridization for the first time here. So we will be discussing the hybridization, in which we are going to discuss the different types of hybridization, sp, sp2 and sp3 hybridization of carbon in detail. Right? So here in this particular session, the content is going to discuss about the carbon introduction to hybridization, among them sp, sp2 and sp3 hybridization. Are you ready? Arish, please wait for some time. I will be discussing detail about the hybridizations. Ready? So please give me something about the idea about the carbon. What do you mean by carbon? It's an element, right? So we have discussed about the metals and non-metals, that we have seen about carbon is a non-metal, right? Carbon is a non-metal. So this is a non-metallic element with the chemical system having the chemical symbol is having capital C, stands for carbon, and an atomic number of 6. Atomic number of 6, right? So if you are drawing the structure of carbon, right, we can represent the carbon as 6 and 12, where this will be the atomic number. And this will be the mass number, right? I hope you must have idea about the representation of different elements. We can represent the elements as with symbol along with their atomic number and mass number, right? So what do you mean by the atomic number? Yes, organic is a part of carbon. Whenever carbon is forming compounds with the other compounds, forming compounds with the other elements, they will form the organic compounds, right? Yes. So what do you mean by atomic number? Yes, it will be the number of protons, right? It will be the number of protons present in the element. So what about carbon? What will be the number of protons in their nucleus? In the case of carbon, I have already mentioned it is have the atomic number of 6, which means that they must have 6 protons, right? Yes, so they have 6 protons. Then what do you mean by mass number? Mass number means the total number of neutrons plus protons, which is present inside the nucleus, right? Total number of neutrons plus protons will be the mass number. So if I am asking about the mass number here, it is written as 12. What do you mean by that? We have already know it is having 6 protons. Then what will be the number of neutrons over there? In the case of carbon, 6 only, right? Total 12, 12 minus 6 is equal to 6 only. So in the case of carbon, we can say that 1, 2, 3, 4, 5, 6, right? 6 electrons are present in the orbitals. Then here, the green represents the protons and blue represents the neutrons. So in total, 6 protons, 6 neutrons and 6 electrons are present in the case of carbon atom. Clear? Is there any doubt? Okay, fine. Now let us talk about the nature of carbon, right? What are their properties? So as you can see over here, carbon is always from covalent bonds. If you are asking about the valency, what do you mean by valency? Okay, Harshit, what do you mean by valency? Yes, it is a combining capacity, right? So here in the case of carbon, how many electrons are present in the valence orbital? These are the orbitals, right? I hope you must have idea about the orbitals. So this will be the first subshell. Then carbon is having two shells, right? K shell and L shell. It can be subdivided into subshells also. So in the case of K shell and L shell, what you are observing here in the outermost shell, 4 electrons are present, right? 4 electrons are present. So we can share these 4 electrons to get the stability, right? Stability is according to the octet rule, in which any of the element which is having the 8 electrons in their valence shell, they will be stable, right? In order to attain the octet, carbon can either lose 4 electrons, either gain 4 electrons, right? So what you're observing here in the case of valence shell, carbon is having 4 electrons. So that will be the valency of the carbon. Is that clear, Harshit? Is that clear? Okay, I hope it is clear for everyone. So let me move to the important properties of the carbon. Because of the valency of 4, they can form the covalent bonds, right? We must have idea about the ionic bonds and covalent bonds. So if you are asking about the covalent bonds, these are the particular bonds in which electron can share, right? It is formed by the sharing of electrons. So carbon can share these 4 electrons to other elements to form the covalent bonds, right? So this is the one of the property of carbon. That's why they are forming more compounds like organic compounds. Clear? Then what about here? Carbon is tetravalent. I have already mentioned, right? If you are asking about the valency of carbon, in the valence shell it is having 4 electrons. So that will be their valency and it can be written as tetravalent. Is there any doubt? No, right? Then the another property is the self-combination. Because of the valency of tetravalent, because of the valency of 4, they can form self-combination, or this property is known as catenation. That is why they are forming more organic compounds also, right? So we will be discussing detail about these properties in the next class. Here I am just giving the introduction about the carbon. Clear? Okay, I hope you understand. Now I am directly moving to the part of importance of carbon here. So carbon is the one of the abundant elements, right? Abundant elements on the earth and plays a crucial role in various natural processes and human activities. So as we already know, carbon is having some versatile nature, right? They can form the catenation property, they can form the covalent bonds, and they will again shows the tetravalency, right? Tetravalency. Because of their nature, they will form allotropes also. I hope you must have idea about the allotropes, right? Some of the elements can form the different physical forms. Such term is known as the allotropes. So here in case of carbon, we will be seeing 3 different types of allotropes, right? What are observing here? First one, diamond, right? So diamond, graphite and Buckminster fullerene. These are the 3 different allotropes of carbon. You need to be keep in mind about that. Clear? The elements which can form in the different physical forms are known as allotropes. Clear, Durgeshwar? Arush, catenation is the self-combining property of the carbon because of the small size as well as the tetravalency. They can have the capacity of self-combination, right? Self-combine. That the property is known as the catenation. So we will be discussing detail about the catenation in the next class also. Fine? Now, why carbon is so important? These are some points given here. Carbon is found in all the living organisms such as part of organic compounds, right? As we already know about the proteins, carbohydrates. I hope you must have studied in the biology classes, right? Proteins, carbohydrates and fats, in which the major constituent or the component is the carbon, right? In the case of carbohydrates, proteins and fats, we can see carbon. So, carbon is very important in our daily life, right? Then what else? In the case of fossil fuels, right, like oil and natural gas, it's again carbon is present. Then again carbon dioxide, as we already know, right, carbon dioxide in the earth atmosphere play a key role in the global carbon cycle or the climate regulation. As we already know about the global warming, right. So in the case of global warming, carbon dioxide plays a crucial role. So that's why carbon is very important as well as the carbon and its compounds is very important. That's why we are going to discuss about the chapter carbon and its compounds. Clear? Okay, just the presentation for the importance of carbon given here. Then again photosynthesis, right, we have already seen. Okay, I hope you can idea about the introduction part. Now I am directly moving to the next part, that is about the hybridization. So I think this is a new term for you all because we are going to discuss more detail in the grade 11 class only about the hybridization. So here I am just giving a brief idea about that, what you mean by hybridization, how we can explain the hybridization in terms of carbon, right? So we have already seen carbon is having tetravalency, right? Tetravalency as well as their self-combination capacity. They will form different variety of compounds due to the formation of hybridization. Now, a question will come in your mind, what do you mean by hybridization, right? What do you mean by hybridization? So you must have idea about the orbitals. So in case of, I will just give a brief idea about that. We have some when we are discussing about the shells and subshells, we will be dividing the subshells into S, P, D and F. Just giving a brief idea about that. So S, P, D and F are the different subshells present in the case of different elements, right? So here, whenever these atomic orbitals, right, otherwise these orbitals combine together to form, they will form another type of orbitals. Whenever any of the two atomic orbitals combine to form two or more new types of orbital, that process is known as hybridization. I hope it is clear. Here it is given as hybridization is a process where carbon's atomic orbitals mix to form new equivalent orbitals. These are known as the hybrid orbitals. Clear? Then what about the electronic configuration of carbon? Anyone please respond in the comment box. Do you have idea about the electronic configurations? Yes, two or more than orbitals combine to form a new orbital. Such a process is known as hybridization, and the new orbital which is forming by the combination of atomic orbitals are known as hybrid orbitals, right? Okay, in the case of carbon, we have already know carbon is having the atomic number of 6, right? So if you are write then the shell electronic configuration, it will be 2, 4, right? 2, 4. We can again subdivide this electronic configuration as in the case of a subshells. So I am just writing this as different subshells, right? So it will be 1s2, 2s2, 2p2. I will give an idea about this. Don't get confused here by getting the subshell electronic configuration. So what you are observing here, 2 electrons in the first shell, right? 2 electrons in the first shell. So this number stands for the first shell. 1s2 means 1 stands for the first shell, which means K shell. In K shell there is only 2 electrons. Clear? In K shell there is only 2 electrons, which is we have already seen in the diagram, right? Then what about the second shell? I mean, second shell means these numbers stands for the second shell. So in the case of second shell, there will be 2 subshells. One is S and another one is P. Are you getting my point? Yes, Arush, we can combine 4 orbitals also to form a new hybrid orbitals. Okay, while completing this chapter, you will get an idea about this, how to write down the configuration, right? Okay, in the case of second shell, we will be having 2 different subshells. One is S and another one is P. So in total, in 2s orbital, there is 2 electrons, and another 2p orbital, there is again 2 more electrons. So in total, 2 plus 2, that is the 4 electrons in the L shell. I hope you understand. Is there any confusions? Is there any confusion? Just let me know. Then only we can move to the next topic. Okay, just note down this. In the case of K shell, there will be only one subshell, that is S. In the case of L shell, there will be 2 subshells, S and P. And for M shell, I mean third shell, there will be having 3 more subshells, that is S, P and D. And for the last one, it is S, P, D and F. Just note it down somewhere. So we have seen the electronic configuration of carbon, right? This will be the subshell electronic configuration of, this is a subshell electronic configuration, and the first one is a shell electronic configuration. So in the case of hybridization, it was introduced by the scientist Pauling, and it means that the shapes of molecules and bond angles can be explained in terms of hybridization. If you have idea about the hybridization, we can just predict the shape of the molecule. Just give a brief idea about here. We will get the idea about the shape as well as bond angles. No need to worry, we will be discussing in detail about the chapter chemical bonding. After completing this, I will go to that chapter only, chemical bonding and hybridization. So here, I have already mentioned the case of hybridization. It is a phenomenon of intermixing of orbitals of the same atom, right? Orbitals of the same atom which have the nearly same energy to form an equal number of orbitals. For example, if you are mixing 2 atomic orbitals, they will forming 2 hybrid orbitals, right? Same number of new orbitals of equivalent energy. That orbitals are known as hybrid orbitals, and the process is known as hybridization. Is that clear? What do you mean by hybridization? Please respond. So again here we are discussing about the configuration of carbon, like electronic configuration of carbon. I have already mentioned it has 6 electrons, right? So the ground state electronic configuration of carbon is 1s2, 2s2, 2p2. 1s, it is in the K shell, and this is in the L shell. So in total it will be 2, 4, right? 2, 4 means 6 electrons, 4 will be the valency. Clear? Now, in order to get an idea about the concept of hybridization, we need to get an idea about the orbitals, right? So here we can call these s orbitals, these are the orbitals. We can represent these orbitals like this, right? This will be our 2s orbital, this will be 2p orbital. In the case of 2p orbital, it can be subdivided into 3p orbitals, right? I know that it will be new terms for you. Just give an attention here. So in the case of p orbital, there will be subdivided into 3 suborbitals, right? Px, py and pz, right? For p orbital, there will be 3 suborbitals, px, py and pz. For d orbital, there will be 5 orbitals. And for s, there is only 1 suborbitals, right? So s here, 2s, 2p. So what you are observing here, in the case of ground level, right? In the case of ground level, there is no any excitation happens, right? In the ground level, it will be having 2s2 electrons and 2p2 electrons. Are you getting my point? Okay, fine. So in the case of 2s2 and 2p2, right? So if I am giving a particular energy to this orbital, what I am observing, one of the electron from here get excited to the vacant p z orbital, right? If I am writing here, it will be px, py and pz orbital, right? So if I am giving an energy to there, it will be exciting, right? One of the electron will goes towards the third orbital, which is in the vacant here, right? So what you are observing here, it will be 2s1, 2p3. This is the excited state. Arush, tell me what is your doubt? Where you got stuck? Did you understand about the electronic configuration of carbon? In the case of carbon, there will be 1s2, 2s2 and 2p2, right? 1s2, 2s2 and 2p2. We will be start from 2s only here, right? In order to get the idea about the hybridization, right? Here in the case of hybridization, I am starting from 2s. So what I need to do, the thing is that we need to form the hybridized orbital whenever they are having only one electron is present, right? So here in the case of 2s orbital, 2 electrons are present, right? So I need to excite these one of the electron. One of these electron I need to excite to the vacant p orbital, right? Vacant p orbital. So what I am doing, I am giving an energy. So one of the electron will be go to the third p orbital, right? Third p orbital or the which was vacant in the case of ground state. Is there any doubt? Okay, you will get an exact idea about these orbitals and hybridization when you are discussing about the chemical bonding only. So just give an attention here. We need to just give an idea about the sp and sp2 and sp3 hybridization in the carbon only. That's why I'm giving an introduction here. Okay, I hope you understand. Right? So here carbon has 4 unpaired electrons, right? One is in the 2s, 3 in the 2p orbitals. Clear? So what you are observing here, now it is almost similar energy, right? 2s and 2p having the similar energy. They are having same number of electrons, right? Each having 1 unpaired electrons. So they will combine. 1 s orbital and 3 p orbital will combine to form an sp3 hybridized orbital. Clear? Is that clear? So we have already seen in the case of ground state as well as excited state of carbon, right? There will be 1s, 2s and 2p orbital. Depending upon our requirement, it will go to the vacant orbitals, right? So what we are observing here, the energy, the orbitals which is having the same almost energy, right? Same energy will combine to form new hybrid orbitals. That's why we can form three different type of hybridization. In case of sp hybridization means one s orbital which means only one s orbital and one p orbital will combine to form how many hybrid orbitals? One s is already there, but the excitation is happening in the case of 2s only. That's why we are not mentioning 1s also. You can just write it down as 1s2 here only, just by words. Clear, Arush? 1s is already there, but the excitation happening from the 2s orbital only. Right? So in the case of sp hybridization, one s orbital and one p orbital. One s orbital and one p orbital to form two sp hybridized orbital. As we already know, if you are taking two atomic orbital, they will form two hybrid orbitals, same number of hybrid orbitals, right? So one s and one p to form two sp hybrid orbital. Then what will be the condition in the case of sp2? How many s orbital and how many p orbital? Okay, Arush, what was our concept about the hybridization? The atomic orbitals having equivalent energy or the similar energy will form the hybridization, right? So if you are asking about the energy here, 2s and 2p orbitals are in the second shell, right? So they will have the almost similar energy. As compared to 2s and 2p, they will having almost similar energy because they are in the same shell only, right? That is why they are exciting from the 2s orbital, not from the 1s orbital. I hope you understand. So in the case of sp2 hybridization, one s orbital and three p orbitals, right? The case of sp2, it will be two p orbitals. So it will form 1 plus 2, which means 3 sp2 hybridized orbital, right? 3 sp2 hybridized orbitals. Then what about in the case of sp3 hybridization? 1 s orbital plus 3 p orbitals, right? To form total 4 sp3 hybridized orbital. Is that clear? Is that clear? So we are going to discuss about the different compounds in which it is obtaining sp, sp2 or sp3 hybridization. In order to get an idea only, I am giving the concept of hybridization here. Okay, pronunciation will be sp2, sp3, not about square and cube, right? This is sp hybridization and second one is sp2 hybridization, not it is not sp square, right? Okay. Now let us talk detail about the sp hybridization. I have already mentioned, right? They will containing one s orbital and one p orbital to form two sp hybrid orbitals, right? Two sp hybridized orbital, as we already know in the case of carbon, right? So what you are observing here in the case of sp hybridization, these 2s and one of the p only combine to form the sp hybridized orbital, right? In the case of sp hybridization, only two orbitals combine to form the sp hybridized orbital. Clear? So from this we can identify that there is a linear shape. There will be a linear shape. I have already mentioned, right, whenever you have idea about the hybridization, we can predict their shape as well as bond angle. So in the case of carbon compounds, if it is having sp hybridization, their bond angle is 180 degree, which is in a straight line, right? That is the shape linear. Clear? Then let us see one example. This is the C2H2. We are going to discuss about the organic compound in detail here. This is acetylene. Let us see the structure here. Okay, before that, this is a pictorial representation of sp hybridized orbital. If you are not aware about the shape of the orbital, we have in the case of s orbital, it will be having the spherical shape, like a sphere, right? It is having the spherical shape. And for the case of p orbital, it will be having the dumbbell shape. Okay, dumbbell shape, right? So this is the shape of sp orbital. So whenever you are having the sp hybridization, these s and p will combine to form sp hybridized orbitals. Clear? Sp hybridized orbitals. Okay, I am not sure about the spelling here. Okay, just take it in your textbook. Okay, now let us see the case of C2H2 molecule. So this is the exact structure of the C2H2 molecule. No need to get confused here. You just want to know about this is the structure of C2H2 molecule, right? C2H2 molecule. As we already know in the case of carbon, right? Carbon, there will be 3 p orbitals. This will be a 2s orbital, right? So what you are observing here in the case of sp hybridization, these two orbital, right, one 2s and one 2px orbital will combine to form sp hybridized orbital. And we have already know, I hope you must have idea about the sigma bond and pi bond, right? If any of the two orbitals are bonding by the axial bonding, they will be forming the sigma bond, right? They will be forming the sigma bond. For example, if I am taking the p orbitals like this, right? If we are combining through the head-to-head bonding, it will form a sigma bond or axial bonding or overlapping. Okay, you need to memorize some of the terms new here about the hybridization and the shape of orbitals and the overlapping. If I am taking the same p orbital, but I am mixing this orbital in a sidewise manner, just like this, sidewise manner. What you are observing, there will be a bond is forming which will be known as pi bond. Axial means there will be in the case of, if you have idea about the shape of orbital, there will be px orbital, right? For example, px orbital means it will form through the x-axis. So just make a note on that. Whenever any of the bond is forming through the head-to-head overlapping, it will form the sigma bond. If they are forming the sidewise overlapping, it will form the pi bond. So what you are observing here in the case of carbon, right? Carbon is having 1, 2, 3, 4 3 p orbitals and 1 2s orbital, right? So what you are observing here, 1 2s orbital and 1 2p orbital will combine to form an sp sigma bond, which means there is the head-to-head overlapping. So this is the sp sigma bond, first one, right? That's why it will be represented as one bond is here. Okay, I hope you are getting my point. This is a new term for you. That's why it will become some confusion. Clear? This will be the sigma bond. Then what is remaining here? 2 p orbitals are here, right? In the case of carbon, it is 1 2py and 1 2pz. So what you are observing here, they are not participating in any hybridization, right? So we can call these as the unhybridized orbital. Unhybridized orbital because they are not participating in the hybridization. Is that clear? So whenever we are having two carbon atoms, one of the sp orbital is forming here and the remaining two p orbitals will overlapping here. That is, this is py orbital and this is pz orbital. So they are forming the sidewise overlapping, right? They are forming the sidewise overlapping. So these two form the pi bonds. Okay, I hope you are getting my point. Okay, how to identify the hybridized and unhybridized, right? In the case of sp orbital, as we already know, only one s and one p orbital will combine. The remaining will be unhybridized, right? If you are asking about the sp2 hybridized orbital, one s and two p orbital will combine. The remaining one will be the unhybridized. Is that clear, Arush? right? So here it is forming the sidewise overlapping, that is the pi bond. So this is the structure of acetylene molecule or CH double bond CH CH triple bond CH molecule. So if you are asking about the bond in the case of CH triple bond CH molecule, one of the bond will be sigma bond and the remaining two will be pi bond because of the sidewise overlapping of other unhybridized orbital. Is that clear? This is all about the structure of CH molecule. Then in the case of CH2 and CH triple bond CH, right? So here what you are observing, one hydrogen atom is there, right? If you are asking about the electronic configuration of hydrogen atom, it is having the electronic configuration of 1s1 because in the case of hydrogen there is only one electron which is present in the 1s orbital. So these 1s and sp hybridized orbital of the carbon will combine to form another sigma bond which is represented by the CH sigma bond. Okay, I hope you understand. Okay, if you are going detail about the structure of p orbital can be subdivided into px, py, pz depending upon the axis in which they are going, right? So in the case of px orbital they will be in the x axis, in the case of py it will be in the y axis, and pz it will be in the z axis. So you must have idea about that. In the case of p orbital there will be three p orbitals are present, px, py and pz. Clear? Okay, what is the shape of s orbital? Arush? Spherical, right? Can we able to predict the spherical shape, whether it is forming axial, I mean head to head bonding or sidewise bonding? How it is possible? So what you are observing here, this is sp orbital, right? This is sp orbital. So this is sp orbital, this is the 1s orbital of hydrogen. So they will form the sigma bond only because there will be chance of axial bonding only or head to head overlapping only possible there, right? That's why they are forming CH sigma bond. So whenever you are asking about the bond in the case of carbon and hydrogen, it will be sigma bond only. There is a chance of pi bonding, right? One is spherical shape and another one is a dumbbell shape, right? sp and one is of hydrogen. So this is the structure of acetylene molecule which is having the sp hybridization. So main points I have written here as the different points given here, right? Just go through the notes after getting the PDF. This is the same I have discussed through the image, I mean in the diagram. Now let us talk about the sp2 hybridization. sp2 hybridization, which I have already mentioned. In the case of sp2 hybridization, one s orbital and two p orbitals combined, right? One s orbital and two p orbitals combined to form the three sp2 hybrid orbitals. Then what will be the number of unhybridized orbital there? What will be the number of unhybridized orbital there? One s orbital, two p orbital combining. Arush? Read the statement properly. I am asking about the case of sp2 hybridized orbital. In the case of carbon, there will be one s orbital and three p orbitals, right? In which one of the s orbital and two of the p orbitals combined to form the sp2 hybridized orbital. Then we have remaining one orbital is there, right? That will be the unhybridized orbital. Okay, I hope you understand now. So the sp2 orbitals form a trigonal planar structure. Trigonal planar shape with the bond angles of 120 degree, and the unhybridized p orbital can form a pi bond. Just like sp, here it is forming a pi bond there. Okay, now we can predict the character also there. in which in the case of sp2 hybridized orbital, there will be having 33.33% of s orbital character and 66.67% of the p orbital. And if you are asking about the sp orbital, sp hybridization, there will be 50-50%, right? 50-50% of s and p characters. Now let us discuss about the structure of ethylene molecule, which means C2H4, or it will be having the double bond. We will discuss later about the organic compounds detail. So this is the compound CH2 double bond CH2, that is known as ethylene molecule. Okay. This is a case of sp2 hybridization. So what you are observing here, this is our s orbital, right, having the spherical shape. This is the px orbital. So what you are observing here, this will be our x-axis. This will be the x-axis. So the shape is over the x-axis. That's why it is calling px orbital. Now it is forming the pz orbital, right? Because the axis is through the z axis, so it will be pz orbital. So what you are observing, one s orbital and two of the p orbital, either px py or px pz. Here I am giving the representation of pz only. So px plus pz gives 3 sp2 hybridized orbital having the shape like this, known as trigonal planar shape with a bond angle of 120 degree. Is that clear? Okay, depending upon the shape we are predicting the bond angle here. You need to keep a note over there. In the case of sp hybridization, bond angle is fixed at 180 degree. In the case of sp2 hybridization, shape is trigonal planar. That is why the bond angle will be 120 degree. Similarly, we can explain the case of sp3 also. Is that clear? Okay, this is the x-axis, this is the y-axis, the remaining will be z-axis. The shape is through the z-axis, so this will be the pz orbital. Okay, now let us discuss about the structure of ethylene molecule. Similar. Yes, similar to the CH triple bond CH molecule, what you are observing here, sp2 hybridized orbitals are forming, right? We can just write down the electronic configuration here. Right? So these one s orbital and two p orbital to form sp2 hybridized orbital, which is forming the head-to-head overlapping. So it is a sigma bond, sp2 sigma bond in between two carbon atoms. I hope you understand. Then what about the case of unhybridized one? There will be the pz orbital, right? Pz orbital in case of one carbon and the another carbon. So they will forming the sidewise overlapping to form the pi bond, right? That is represented here. In the case of C double bond C, one of the bond will be sigma bond and another bond will be pi bond. Is that clear? Is that clear? Then similarly, in the case of carbon and hydrogen, hydrogen is having the 1s orbital. This 1s orbital will be forming the head-to-head overlapping of the sp2 hybridized orbital of carbon to form sigma bond. So 1, 2, 3, 4 CH sigma bonds, right? Then 1 CC sigma bond, again 1 CC pi bond. So this will be the structure of CH2 double bond CH2 molecule, which is an example of sp2 hybridization. Is there any doubt? Okay, you didn't study anything about the electronic configuration or the shape of orbitals. So we can just express the electronic configuration in terms of box configuration, right? Box. So here First box represents the s orbital. 1s2 I am giving here as numbers only, 1s2. So this will be the 2s2 orbital. So if I am giving an energy to the carbon atom, as we already know, there will be 2 electrons present, right? First case. So if I am giving an energy, one of the electron will excite to the third p orbital, right? Are you getting my point? So one of the electron will goes to the third p orbital in the case of carbon atom. So I have already mentioned in the case of p orbital there will be px, py, pz orbital, right? P can be subdivided. So this can be represented as a box of 3 columns, right? 1, 2, 3. So this will be, first one is the px1, second one is the py, third one is the pz. Is that clear, Arush? This is in the case of carbon. In the whole chapter we will be discussing about the case of carbon only. Is that clear now? Then these arrows represent the number of electrons. These arrows represent the number of electrons. So here in earlier case, in the ground state, there will be 2s2 electrons, right? 2 electrons are there. So one of the electron from the 2s orbital will be excited to the pz orbital. So we will be discussing in the case of excited state only. I hope now you understand. So this is the structure of CH2 double bond CH2 molecule. The same thing I have given in the words also. Clear? It will form the CH sigma bonds. Then there will be one sp2 sigma bond and pi bond also present. Yes. Right. Overlapping sidewise to form a pi bond between the carbon atoms. Arish, which point you are asking about? This one, right? So in the case of CH2 double bond CH2 molecule, what you are observing? In total 1, 2, 3, 4 CH sigma bonds, right? 4 CH sigma bonds are present. Then in the case of double bond, 1 is sigma bond, right? 1 is CC sigma bond. So 1 CC sigma bond, then 1 CC pi bond. Clear? Now we will be moving to the last type of hybridization, that is the sp3 hybridization. So what do you mean by sp3 hybridization? 1 s orbital and 3 p orbitals, right? 1 s orbital and 3 p orbital combined to form 4 sp3 hybridized orbital or 4 sp3 hybrid orbital, right? So it will have the tetrahedral shape and the bond angle of 109.5 degree. Just recall about the sp hybridization. What is the shape of sp hybridized orbital? Sp hybridized orbital, what was the shape? In the case of sp orbital, it will be having, in the case of sp hybridization, shape is linear with 180 degree, right? sp2 means trigonal planar with 120 degree. Here it is tetrahedral shape with bond angles of 109.5 degree. Clear? So let's see one example, that is methane molecule CH4 having the hybridization of sp3 orbital. Then what you're observing, each sp3 hybrid orbital has a 25% of s character and remaining 75% will be the p character. So this is a case of sp3 hybridized orbital, right? Okay, this is our s orbital. This will be the px orbital. This will be the py orbital. And this will be the pz orbital, right? So 3 p orbitals and 1 s orbital to form sp3 hybridized orbital having the shape like this. This is sp3 hybridization. So many mistakes are here, just note it down here. So this is the s orbital, px, py and pz combined to form sp3 hybridization. This will be the shape of sp3 hybridized orbital having a bond angle of 109.28 degree. Then shape is tetrahedral. Clear? Okay, just for a representation we are giving there like this only. Clear? Okay, now let us discuss about the structure of methane molecule. If you have idea about the ethylene and acetylene molecule, you can get an idea about the methane also here. So what you are observing in the case of ground state, 1s2, 2s2, 2p2, right? 1s2, 2s2, 2p, sorry 1s2, 2s2, again there is a mistake. 1s2, 2s2, 2p2, this is the ground state. If I am giving an energy, it will excite, right? One of the electron from the 2s will go to the pz orbital. So in total these 4 orbitals, right? One of the s orbital and 3p orbital combined to form 4 sp3 hybridized orbital. That is a sp3 hybridization. Clear? Arush, you need to keep in mind about the case of sp, sp2 and sp3 differently. Okay, sp means linear 180 degree, sp2 means trigonal planar 120 degree, sp3 means tetrahedral 109.28 degree. Some exception will be happen depending upon the molecule. So for your reference, in the case of carbon-anion compounds, we need only these 3 types of hybridization. Clear? So what you are observing here, one of the s orbital and p orbital combined to form the total 4 sp3 hybridized orbital. So here it will be the 4 sp3 hybridized orbital represented by this, right? Only one carbon is present, so it will form the sp3 hybridized orbital. Then what you are observing, 1s orbital of hydrogen will form the head-to-head overlapping, right, with the sp3 hybridized orbital. So this is also sigma bond. So how many sigma bonds are present here? 4 CH sigma bonds, right? Is that clear? So bond angle is 109 degree 28 minute. Having shape of tetrahedral. Arush, I didn't get your question about the sp2 hybridization. Are you asking about this thing? Okay, if you have idea about the hybridization, you will get the idea about the bonds here. What you are observing here in the case of sp2 hybridization, right? 2 carbon atoms are present, right? One of the carbon atom is sp2 hybridized here, another one is again sp2 hybridized. So these sp2 hybridized orbital have the capacity to form overlapping in the head-to-head. So this will be the CC sigma bond. CC sigma bond. That's why I have written here. CC sigma bond is equal to 1 over here, right? Then there will be unhybridized orbital, right? There will be one unhybridized orbital, that is pz. It can overlap to form pi bond. So that is represented by the CC pi bond is equal to 1. Clear? Then what about the next? Hydrogen is having the 1s orbital. So it has the capacity to form a sigma bond with the sp2 of the carbon, right? So they will form 1, 2, 3, 4. In the case of CH2 molecule, there will be 4 hydrogen atoms. So it will form 4 sigma bonds with the carbon. So CH sigma bond is equal to 4. Yes, you can just draw the structures in the case of hybridization. Okay, I hope you understand about the structures, right? In the case of sp, sp2 and sp3 hybridization. We are giving some examples in the case of sp, sp2 and sp3 in different case. Clear? So this is about the sp3 hybridization. Same, I am just giving the keywords here. The case of sp3 hybridization. And again, number of bonds will be 4 in the case of sp3, 25% S character, Then for sp2 it will be 3 number of bonds, 33.3% is S character, and for sp total 2 bonds forming 50% of S character. Okay, that's all about from my side for today. We have discussed about the thermo hybridization, sp, sp2 and sp3 hybridization. I hope you understand. Now let us practice some questions here quickly. Please give me the answer first. In ethene molecule C2H4, each carbon atom is C2H4. We have discussed, right? What will be the answer? This is our molecule, ethene molecule, CH2, which means it is a double bonded molecule. So what will be the answer? It will be sp or sp2? sp2, right? sp2 is the hybridization, so option B will be the correct answer. So just go through the structure, then you will get an idea about the hybridization. Fine. Here is our next question. What is the geometry around the carbon atom in a sp hybridized state? sp hybridized state. Yes, shape is linear, right? Yes, shape is linear with bond angle of 180 degree. Here is our next question. What is the bond angle in a molecule where carbon is sp3 hybridized? We have discussed in the last case, right? What is the bond angle of where carbon is sp3 hybridized? Yes, 109.5 degree, right? Exactly the angle is 109.28 degree, but you can give the answer as 109.5 degree. It's also fine. Irish, there is no any possibility of forming a bond of CH2 because carbon has a minimum valency of 4. It cannot form only 2 electrons, right? With 2 hydrogen atoms. Here is our next question. Which hybrid orbitals are involved in the formation of CH bonds in CH4? CH4, methane. We have discussed in the last case, right? It is about the sp3 hybridization. Okay, after completing this session, just watch through the recorded session, then you will get an exact idea about the hybridization, then practice these questions, fine? By practice only, we will get an idea about the hybridization concept. So, now I am directly moving to the next question. What is hybridization? Okay, I will give the answer first because there is a time limit for us. Mixing of atomic orbitals to form the new hybrid orbitals, right? So option C will be our correct answer. That is the definition of hybridization. Clear? Okay. Next question. Which of the following molecules exhibits sp hybridization? sp hybridization. We have given the structure along with the hybridization. Watch the recorded session after completing this. Go through the practice questions. Right? So what is our answer here? Acetylene molecule, right? C2H2 molecule because it is the CH triple bond CH, right? Structure is already given, just go through that. The next question, what is the atomic number of carbon? Simple question, right? Atomic number of carbon. Yes, option B, 6. Then let's just recap the session we have discussed today. This will be the summary. Carbon is essential compound, right? We have seen about the carbon. It is very important in our daily life. So it will form hybridization, right? They have the capacity to form different compounds because of their valency is 4 or it is a tetravalent compound, right? So they have the capacity to form they have the capability known as catenation. We will discuss in the case of organic compounds, right? Then here we have discussed about the hybridization. This will be a summary about the hybridization. I hope you understand. Okay, you need to learn about the 3 different structures here in the case of sp, sp2 and sp3 hybridization. Fine? Okay, that's all about from my side for today. I hope you understand about the concept of hybridization. I am repeating once again, just go through the recorded session to get an exact idea about the hybridization concept. We don't get an exact idea whenever we are going to the live classes. You need to practice more, right? Okay, I hope you guys enjoyed the session. If you really like the session, hit the like button, subscribe our channel, share this particular session to your friends also. And if you want to get the session PDF, you want to join our Telegram channel, Infinity Learn 9 and 10 channel. So thank you so much all of you. See you in the next class. I will be coming back with the isomerism part of the carbon compounds in the next class. Thank you so much all of you.